Hello everyone, in this video I'll teach about the merge sort. I already teached you about the bubble sort. Don't think that I am skipping the insertion sort, selection sort. I'll teach in the next lectures, but in this video I'll teach about the merge sort. Time complexity or space time complexity of the merge sort is O of log n log n. So we need to merge sort it. So I am given an example of the array. It is the array. So we need to sort it in the ascending order. So in the merge sort, it is a little bit lengthy if we compare it to the bubble sort, but the time complexity is obviously it is much lesser than bubble sort. It is n log n, and bubble sort it was n square. So how to sort it? We just need to. I'm just dry running it the array. How the merge sort works? We just need to divide it from the middle, of the array. We just need to divide it. At first, we are dividing the array. That is 2, 3. Sorry for my handwriting because I am just writing on the desktop with the mouse, so it is obvious. So we are dividing at least one elements, so we are dividing it like that. At the last, the length of the array is 1. We will think about that how we are implementing by the code, but at first we are taking the tree, we are taking the dry run, we are dry running the merge sort, that how it actually works. Then we will go to the code. So we are divided. The minimum length of the array now is 1. So we cannot divide it. We cannot divide it any further. So we are now just stopping here. Now we are conquer the array. We are divided step by step in the recursive manner. I think you all guys know what is recursion. So I'm just skipping the recursion part because I think you all guys know how recursion works. So at the recursive way, it is the array is dividing from the mid. In this also, it is dividing from the mid. In this length, it is dividing from the mid. So at least we need to divide the whole array at least one element. Okay. So now we need to conquer such a way that the array is sorted in the ascending order. It is sorted. Now we are conquering the array. So it is 1 9. Now we are conquering the final array. So what will be the sorted array? For me, it is the length of 4. So it will sort. How we will sort? How we are sorting by the code? I will discuss it. Obviously I will discuss it. So just understand it, how it works, how the merge sort is. The merge sort is working on the uh, divide and conquer concept. You can see that at first we are dividing from the mid. Then the array we are dividing it also from the mid. We are dividing the whole array as of, means until we are getting the 1 elements in every array. It is obviously we will do at the recursive manner. Then we are getting upwards, means we are completed the dividing step. Now so we are now conquering the array in the ascending order. We are conquering the array in the ascending order until we get the final result, which is 1 2 3 9. So it is a little bit complex if we compare it to the bubble sort, but it is much more efficient from the bubble sort, and it is the most important sort you can get in the campusing. So it is an algorithm. So you all guys know that I made a website that is about the sorting algorithm visualizer. So here is also uh, a button for the merge sort. You can see that if I am merging it, you can see that half, then it is conquering, conquering. It is dividing now, it is conquering, conquering, and now it is conquering. Now it is conquering. The final is conquering. So as of now, I just forgot to share the link of my website. I will share the link of my website in the description box in this video. I will also edit the previous video description. So just understand how it works. Now I'm jumping into the coding part. I think you all guys understand that how it is working. It is working as a concept on the concept of divide and conquer. So going to the code. So at first I need the array. Obviously I need the array length. I can also take the vector. Let's leave it. I am taking an array of length of maximum length of the array is let's say 14, and I am taking a input. I am taking the length of the input, and I am just taking the array elements as the user input. So see in what I am taking, array of n. I think you all guys know. Sorry, array of I. I think you all guys know how to take the inputs of the array. You must know. If we are in the video of the merge sort, you must know how to take the input in the array. So just you're taking the input in the array. Then what was the first step? You need to first divide it from the middle. Okay, so I need a function that is called the divide. um, what I am taking in the divide part, that is the array, and I'm taking as a pointer variable, pointer array. And you need to take the starting index, you need to take the ending index, as you need to divide it in every step from the middle. So what is the division part? What is the division part? Just understand. 0, what is the index of the array? 0, 1, 2, 3, and the starting index of the array is 0, and the ending index of this array is 3 at first. So what is the middle? 0 plus 3 divided by 2. What you are getting, that is the result 1. So the middle index is 1, means this, and you are dividing it from starting index to middle, it is the middle index, and middle plus 1 means 2, middle plus 1 to the ending index. You are dividing in this way, starting index to middle, middle plus 1 to ending index. So obviously you, if I'm telling you that if you are understand, if you understand the dry run concept and the concept of the merge sort, you can code it easily. So just what I have just studied, that array, it is at first it is starting from starting index to middle, and you need to just calculate what is middle, obviously. So what is middle? Si plus, sorry, si plus ei divided by 2. This is a middle, and now we need to just divide it. We need to divide it another thing, that is middle plus 1, another half, middle plus 1 from middle plus 1 to ending index. So we need to divide it. So divide, we are dividing it in this way. So we are divided, but now we need to what is the main concept of recursion? We need a base condition where the recursion stops. What is our base condition? Our base condition is, this is our base condition, means when the array length is 1, when the, so understand what is the base condition of the array. So what is the base condition? When the array length is 1. So how we can calculate when the array length is 1? When we can see that the starting index and the ending index, when the starting index is greater or equal than ending index, then we can say that it is like it is the one, it is the base condition, the array length is 1. So we are just implementing that thing, that when the starting index is greater or equal ei, then we just need to return that we have reached to the base condition. Now we have to do the other things. Now we have to do the conquer part. So what was the conquer? Conqueror. Pardon me if I do any mistake on the on the spelling. So just leave it. And what is needed in the conqueror? Just let's see what is needed in the conqueror. Just copying it, and just int array. What is needed in the conqueror? Int si int mid. We also needed the mid position and the ending position. Okay, so just understand what we need to conquer. What we need to conquer. So you can see that we have reached to this position. Sorry, we have reached to this position. So we need to conquer the 2 and 3. Means we have this array. We need to conquer this 2 and 3. So how we can conquer it? We need to, at first we need to short. We need to short the array. And conquer means we have two arrays in the conquer function. We need to short it and merge it in another array, and now copy the merged array into the real array. So at first we need a merged array. So we are just taking a merged array, which is the length of starting index plus ending ending index minus starting index plus 1, obviously. Okay, because it is zero based indexing, so size is plus 1. So now what you can do, understand how how we will conquer. At first just pass the conquer thing, conquer like parameters mid comma ei. It is the conquer parameter, so we need to implement the conquer. So how we can implement the conquer? Just understand this thing. If we are in this level, it will easier to understand. If I am just I will teach you in this level. So if you are in this level, you will get the merged length of ending index is here, starting index is here. So 3 minus 0 plus 1 means 4. So merged length is 4. It is 4. Now the pointer, we have two arrays, that one is starting index to starting index, from starting index to mid, and one array is from mid plus 1 to ending index. We have two arrays. We need to merge it in a way that it is sorted. So we are pointing in this array at the first element. We are pointing in this array at the first element. So we are checking which is small. So which is small? 1 is small. We are putting in the merged first is 1. Then we are increasing it. We are checking this 2 and 9. 2 is small. We are putting 2. Then we are increasing this. We are checking 3, 9. What is small? 3 is small. We are putting this, and it is go out of the array. And now, which array is not completed? Complete the array. Just put the elements as like simultaneously, because it is already sorted. The previous step is already sorted. Just put it. Just what is it is already completed. It is not complete, so it has 9 and 9. In that final step, we are getting the result. So what is this? How can we do the coding part? We are making the merged array. We are making the merged array as that length of ending index minus starting index plus 1. So what we need to do, just point the two elements, means one is from the starting index. Point out the two indexes. Okay. So what is this? Just I is the si, and the j is mid plus 1. Okay. So we have pointed the first element of the two arrays. So what we need to do, just while I is lesser than or equal to mid, and j is lesser than or equal to ei, because j is the first pointer of the second array, and I is the first pointer of the first array. So the length of the first array is I to si to mid. So I need to lesser than mid or equal to mid, and j is starting from mid plus 1, but j need to lesser than ei or equal to ei. So that is the condition. And what we are checking in this condition, if array of I is lesser than array of j, means I is smaller. Obviously we need a counter that is pointing out the merged array. So what we are doing, that merged of x equals to what is small? I is small. So just put the ith element of the array to the merged. And now we need to increment the x. Obviously, we need to increment the x, obviously, and we need to increment the I, obviously, because we put it the ith element. So I just use a post increment. Obviously, I think you already know what is post increment and what is the use of post increment. So I have okay. So else, what is the else? Else means jth array is bigger, means jth element is bigger than I. So merged of, obviously, for now, means in this position also x plus plus means an array of j plus plus, and I have completed this. And just in every step I'm comparing with the code from the diagram, because you need to understand also that how the code works, how in every step in the diagram how I am implementing it into the code. So what is this? I is this, j is this. As the first counter, I is this, j is this. We are comparing what is small, I is small, and x is this. Okay, x is this. It is a merged, it is a merged array. X is this. What is smaller? I, one is smaller, one is smaller. Okay, we are implementing one. Now I is here, I is now here, because we are not incremented, because I is not smaller than the j, I was not smaller than the j, so j is was incremented. Also now we are comparing with 2 with 9. What is smaller? 2 is smaller. We are incrementing I, not j, and we are incrementing also the x is here. Now we are comparing 3 with 9. What is smaller? 3 is smaller. We are here, 3 is put it, and x is now here, but we are getting I greater than mid, means I is not lesser, not equal to mid. I is now greater than mid, but we have one more element in the second array. So how can we deal with that? So I'm just doing it. And in this after this step, I don't know that what which array is finished. So we need to implement the two while loops for the two arrays. Means I less than equal to mid, while I less than equals to mid, merged of x plus plus equal to array of I plus plus. Same for the second jth, same for the jth array. So just j. I have implemented the merged. I have gotten the merged element, but I can also in this step I can also pass the merged element to this to that. But into just it is hard to handle the passing of array because I'm using pointer. So just traverse. So just traverse to the merged array. Merged dot size. What is the merged size? I don't know. The merge dot size, the size dot size function will execute what is it. So now I'm just copying the merge result to this result, and now after that I am checking if I am getting the correct result or not. Okay, so just like that. Okay, so one thing I have mistaken that you also understand the thing whatever I have mistaken, because it is a really crucial thing. Like when we are getting the merged element indexing is just like normal 0 1 uh, 0 1 2 3, just normal. But it is not normal in the real array. The real array is not always starting from 0. The real array is starting from si, means the real array is starting from the starting index every time. So we need to start the ith element from 0. Like from the merged element counter is from 0, but the array element counter must be from the starting element of that conquer step. Of this conquer step, the counter is always from should start from the si. So I am mistaken in that line. So what will be this? I is the pointer of the merged array. What array I have sorted? The sorted result is that, and j is the uh, see that j is the starting index, and array dot size will not work because dot size function is not for array. Dot size we use in the vector stack queue in these STL functions. So what is the length of the array? ei minus si plus 1, easy, and obviously j plus plus. Okay, so what is I am doing? What I am doing, that array of j is the starting of array, j is the starting point of array, and the merged I is the starting point from merged. That's the thing. So and I will rotate in this means at the length of this. So just run it. Let's see whether it will give the right output or not. Just five. What was our input? What was our input at first? At first we are getting the input of the length of the array. The length of the array is 5. Now enter 5 elements, 4 1 2 7 5. We can see that we are getting the array in the sorted order, means 1 2 4 5 7. So just understand the driver of the merge sort. Understand how the merge sort is like implementing. I'm implementing how I am implementing the merge sort. At first we are dividing the array, then we are conquering the array in the sorted way until we reaches the final array. You guys have understand the topic. I know that this video is a little bit lengthy, but just give you effort to do the martial because it is really important for your campusing and also for my campusing. So just give you effort. And if you have any doubt, you can ask me on LinkedIn, Insta. I'll give the link of my LinkedIn and Insta. You can also ask me in the comment section. I will reply. And if you like the video, like and subscribe and share with it with your friends. See ya. Have a good day. Bye.